So in question 9, a student is given the following information for a particular attempt at a goal. Initial velocity of a ball is 4.5. The horizontal angle with the horizontal is 60 degrees. The range, the horizontal distance from a center of the ball to the ring is 1.5. Show that the time to travel the horizontal distance of 1.5 is about 0.7 seconds. So we want to travel, because student giving the following at a particular attempt at a goal. So student attempting a goal, initial velocity is 4.5. The ball is released at an angle of 60 with a horizontal. So 4.5 and 60 degrees. And the distance from a center of the ball to center of the ring, that the horizontal distance is 1.5. We have to find the time it take to travel the horizontal distance of 1.5, which is about 0.7 seconds. So whenever range is given, speed is equals to distance divided by time, or distance or range is speed multiplied by time. So distance travel is 1.5. And what about the speed? Because we have the horizontal distance, so we need a horizontal component. So what will the horizontal component of the speed? That will be 4.5 cosine 60 or cos 60 into t. So it will be 1.5 divided by 4.5 cos 60. Why I did not use a vertical component? Because vertical component affect the vertical motion, the height, not the range. So 1.5 divided by 4.5 cosine 60, what's the answer? Which is approximately equal to 0.6 seconds, 67. So 0.67 is approximately equal to 0.7. So 0.67 seconds, which is approximately equal to 0.7. Look, sometime maybe you're not able to solve the first part, so you can use the answers which are given here, because the next question you need the time. So for this time you have to use in the next part. That's why if you are not able to solve the first part, you can use the given answer to do the second part. The second part, calculate the vertical displacement of a ball when it has traveled the horizontal distance 1.5. So when the ball has traveled a distance of horizontal distance of 1.5, the question is at what height this ball is. So it traveled 1.5, we have u, which is 1. U is 4.5 and the angle is 60 here. 4.5 and angle it is making is 60 degrees. But this h is not the maximum height, so we cannot take the final velocity, final vertical velocity 0. We cannot take. Why we cannot? Because h is not the maximum height. Maybe it continue to rise, maybe it's just coming down, we are not sure. That's why we just need the height of this projectile when it covered 1.5 meter horizontally. So when it covered 1.5 meter horizontally, it took about 0.67 seconds, or I can say 0.7 seconds. So whenever we are finding a vertical motion, we always use the equations of motion. So that is like S is equals to ut plus half at square. So u is the initial velocity, but that initial is not the total initial, it is a vertical component of initial velocity. So what is the vertical component of initial velocity? That is 4.5 sine 60 multiplied by t, which is 0.67 second, plus half. Expression is due to gravity, it's moving against the gravity, so minus 9.8, and time is 0.67 square. So simplify. So when we simplify this, the maximum height will come out as the vertical displacement will come out around 0.41 meter. Then comment, as I mentioned, the vertical distance from a ring, from a release point, like there is a ring. Basically, there is a question, there's a ring. It can be in this manner, or example, the ring is in this manner. Okay. And a person shoots the ball with the initial velocity of 4.5 at an angle of 60. And the ring, the horizontal distance of the ring is 1.5 meter, and the vertical distance of the ring is 0.7 meters. But when we calculate the vertical distance, when it covered 1.5 meter, the vertical distance of the ball is only 0.4 meter. So can this ball passes through the ring? So comment is the ball cannot pass through the ring because at 1.5 meter distance, the ball is at a height of only 0.4, where the ring is placed 0.7 meters. So this ball will undershoot the ring, like it will move to bottom of the ring, does not able to cross the ring or pass through the ring. Is it clear, this one?
Yes.
Any doubt? Okay. Explain how air resistance would have effect on calculation in B. So if there is the air resistance, what will be the effect? That air resistance will affect the horizontal speed. So it will not cover the same range or 1.5 meter, or it will take a longer time to cover that 1.5 meter. So both ways you can mention, either you can mention it will not cover the same, maybe 1.5, or it will take longer because the horizontal speed decreases. So it will take the longer time to cover this 1.5 meter. Another question related to a projectile. Mangonel is a type of a catapult used to launch a projectile such as rocks. A student made a working model. As a handle turned, the arm is pulled back by a spring. This increases the tension in the rubber, and when the string is released, the rubber band causes the arm to move upward and launching a projectile from a bucket. When the arm hits the crossbar, so basically the same idea. It is the same idea of launching a projectile which we did in question, the previous question. So what student did, student make a catapult, a type of a catapult, but this time it is not using the weight here. And what student did, the vertical part is there, like this is the vertical part. Now, this is the vertical part. So this is the vertical part here. And what student did, student attach a rubber band, like connect rubber bands here. Okay. So when student pulls, the rubber band will store the elastic strain energy. And when the student release, so this arm will go up, and this part is also not there, like the projectile is placed, the object is placed here, or a small piece of rock is placed here. So when this arm will move, like elastic strain energy change to kinetic, when this arm hits the vertical part, that position the projectile will be launched. So at that position, the projectile will be launched and it will move in this manner. So this is what the student design, according to the information given, that's a design of the student. Now what we have to do in the question, here in question 9, students show that the time, sorry, question 10 was there. So suggest why a rubber band is used to support the arm. So what is the reason why we are using a rubber band to support the arm? Because rubber bands, it's an elastic material, so it can store greater amount of elastic strain energy. So projectile can be launched easily. So answer here. And rubber band, another tendency of a rubber band, it can transfer its elastic strain energy easily, as it can deform. So the idea of using a rubber band, that it can store elastic strain energy and transfer that elastic strain energy easily, so the projectile can be launched. Is it clear? Why not any other material is used? Because the other material will not be efficient to transfer the elastic strain energy. Those objects which can deform can easily transfer the elastic strain energy. Then state the energy transfer that occur when the spring is released. So what is the energy transfer which happened here? So initially, it will have the elastic strain energy. Then when it is launching, the object is moving up, so potential, and then to kinetic. So elastic strain energy plus it's going up, so potential and kinetic is there, and some heat energy, because like here, the vertical part, then this is the arm of the projectile, and it is connected by the rubber. And here we place a projectile. So first, elastic, because we stretch the elastic strain energy, when this arm is moving, so it is having potential and moving also kinetic. So you can say the elastic strain energy changes to kinetic plus potential. Both energies will be there, as it is at certain height and it is moving. The student varied the angle to the vertical at which the arm is released. So this is the change in angle to the vertical. Mean like example, so this is the vertical parts. I'm drawing different positions, the vertical part. So here first it is launched with an angle of 15, then it is launched with an angle of 30, then 45, and then 60. So which one will have a greater, because when we increase the angle, the rubber will be stretched more. So if rubber is stretched more, greater amount of elastic strain energy. If greater amount of elastic strain energy, if I say A, B, C, D, which position likely to produce a greater range of a projectile? So that will be position D. Why position D? Because its angle is more. So it's the elastic strain energy, as the rubber deform more, a greater amount of elastic strain energy. So range of the projectile will also increase. So the question, and it's a 4 mark. Explain why the range increases as the angle increases. So what are the points you will mention? Number one, as we increase the angle, so the rubber will deform more, or rubber band will deform more, so greater amount of elastic strain energy stored. That is 1 mark. So when it is launched, so potential energy is same, because it is all are launched from the same height. The final potential is same. The change in potential is different, but the final potential is same. So the greater amount of kinetic energy will be transferred. If greater amount of kinetic energy transfer, we know kinetic energy is half mv square. So if more kinetic energy, mass is not changing, so speed will also increase. If the launching speed increases, the range of the projectile will also increase. So how you score 4 mark? Number one, when the angle increase, rubber deform more means greater elastic strain energy. When it is launched, greater amount of energy converted into kinetic, and if increase in kinetic, increase the initial speed, which increases the range, because the range of the projectile depends on the initial speed as well as time. So if you increase the initial speed, the range will also increase. Is it clear, this one?
Yes.
A student replaces the projectile with a smaller mass. State why this increase the range. Look, because the elastic strain energy is converted into kinetic. And what is kinetic energy? Kinetic energy is half mv square. Because the projectile is launched with the same angle, so the kinetic energy is same. If kinetic energy is same and we are using a small mass, so the speed of the projectile should increase. As the speed of a projectile increases, the range will also increase. Or you can also mention smaller mass also refers to that it will have a lower air resistance. So it will have, and as a result, it will also travel a greater distance. So higher kinetic energy, same kinetic energy for a small mass, so speed increases, launching speed increases. So as a result, it will have a greater acceleration or greater initial speed. That's why the range increases. Then suggest one modification to the model that would increase the range and give a reason for, like how we can modify this model to have a greater range. Like, so what we can do, first we were using only one rubber band. Example, if one is, so we should use two more bands. As a result, when we'll use two bands, more or a greater amount of elastic strain energy is there. So as a result, greater amount of elastic strain energy, more kinetic energy, so the range will also increase. So we can double up the number of the bands, or we can, what else we can use? We can use stiff bands. Stiff bands mean, stiff rubber band means like it will be difficult to deform. So we can use a stiffer band, or we can use a smaller rubber band, because smaller rubber bands, when it is released instantly, it will transfer energy as compared to. So if you mention a double up or increases the number of the band, it will increase the force or tension or increase the amount of kinetic energy. If I say I replace with a stiffer bands or a shorter band, that it will increase the energy stored or work done. Or what else we can use? We can use a longer arm, because if you use a longer arm, like there will be more greater change in the potential energy. As we are using a longer arm, so greater change in the height, so the range will also increase. Like example, if I launch a projectile, say from this height, and I use a longer arm and launch a projectile from another height, so greater height means it will have a greater range because it will travel for a longer period of a time. Shorter height means small range, so it will have a, like it will take a less smaller time to hit the shorter time to hit the ground, so the range will also decrease. When student wishes to place a target in a path of a projectile, the height of the target is 5 centimeters. So there is a target is placed. There's a target place which is 5 centimeter height, and the projectile is released from a height of 13 centimeter. So this projectile, the object or a rock, is launched from a height of 13 centimeter. And this one is 5 centimeter. Show that the time for a projectile to fall to a height of 5 centimeter is about 0.1 seconds. So we have to show when this projectile is launched, it will take about 0.1 second to reach 5 centimeter. So what is the change in the height? Because we always we take how much change in the height is there. If total is 13 and this is 5. So what height is changed for the projectile when it is launched from a overall height of a 13? So the change in height will be 13 minus 5, which is equals to 8. So we have to show that it to cover 8 centimeter height, it took only 0.1 seconds to do this. So when a projectile is launched from certain height, what is the initial vertical, horizontal velocity is there, but vertical velocity is 0. So we use the equation of the motion, which is S is equals to ut plus half at square. The initial vertical velocity is 0. Whenever projectile is launched from certain height, the vertical velocity is 0. So this whole factor will be 0. So it will be S equal half gt square. S is the height. H is not the total height. H is a height which the projectile fall from the launching position. So that is equal to 8 centimeter or 0.08. Because SI unit of length is meter, so 0.08. Then half acceleration is due to gravity 9.81 and time square. So t square. So it will be 0.08 multiplied by 2 divided by 9.81 and take a root. What is the answer? 0.082 multiplied by 2 divided by 9.81 in a root. How much is this? The total? 0.08 times 2 divided by 9.81 in a root.
It's 0.127.
So 0.127 or 0.12. So time is 0.12 seconds. So that is correct. We have to show around 0.12 seconds. Is it clear this one?
Yes, sir.
The next
Yes.
part, they ask where we should place the target. Like what is when an arm was pulled back at an angle of 60. So this arm is being pulled back at an angle of 60. The time taken for a projectile to travel horizontal distance 1.7 meter was 0.16. Calculate the minimum horizontal distance that the target should be placed from the model for a projectile to hit. So when the angle is 60, it covers 1.7 meters. That is the total range. And it took 0.16 seconds. So and remember, it is launched from a height of 13 centimeter or 0.13. So a projectile is launched 13 centimeter from a height of 13 centimeter. We have a target which is only 5 centimeter height. The question is where we should place a target so that the minimum horizontal distance, like the total range is 1.7, like this projectile can cover 1.7. But what distance we should place a target so that the projectile should hit a target. And the total horizontal, it took about 0.16 second. That's a total distance. So first what we will do, we'll find the horizontal velocity. So how to work out the horizontal, because horizontal velocity does not change. So we have the range of the projectile and we know the time. So first we'll find for 1.7 meters, what is the horizontal velocity? So speed is distance divided by time. Speed is distance divided by time. So the horizontal or launching speed, distance divided by time, distance is 1.7 and time is 0.16. So 1.7 divided by 0.16. That will give us the horizontal speed, which is 10.6, 10.62 or 10.6, I said. So it is launched at a horizontal speed of 10.6. Now, if you check the previous part, it was taking, because it was taking about 0.1 seconds, 0.13 seconds to, or 0.12 seconds to reach the target. That we already, because it, both parts are interrelated. So we got the horizontal speed and we know the time to hit the target was 0.12 seconds. So time to hit the target is 0.12 seconds and the launching speed is 10.6. So now we'll find what is the what is the horizontal distance, this distance. So again, we use the same formula, speed is distance over time, but this time we're finding a distance which is speed into time. The speed is 10.6 and not the total time. This time the time is 0.128 or 0.12. When we multiply, what is the answer for the distance? 10.6 multiplied by 0.128.
1.27.
1.27 meters or 37.
27.
Okay, 1.27 meters. Is it clear? This one. So first, using the total range and the total time, we got the horizontal speed. And from the horizontal speed, we know that it is hitting a target after 0.1 seconds. So we multiply by 0.1, we got the final answer.